Today we are going to demonstrate the standard Proctor test method used to determine the maximum dry density and optimum moisture content in accordance with ASTM D698. This video will cover the process of compaction test for a given fine-grained soil sample. There are two types of Proctor hammer, standard Proctor and modified Proctor. In this experiment we will use standard Proctor method. Take approximately 4.5 kilograms of soil, pulverize the soil and run through the number 4 sieve. Determine the weight of the soil sample as well as the weight of the compaction mold with its base, that is, without the collar, by using the balance and record the weight. Measure the amount of initial water to be added to the soil. We will use 6 different water content varying from 6% to 24%. Add the measured water to the soil and mix it thoroughly using a trowel until the soil gets a uniform color. Assemble the compaction mold to the base. Put the cover on top of the mold. Place some soil in the mold and compact the soil in 3 layers with 25 blows each layer. The drops should be applied at a uniform rate not exceeding around 1.5 seconds per drop. The soil should completely fill the cylinder and the last compacted layer must extend slightly above the collar joint. Carefully remove the collar and trim off the compacted soil. Weigh the compacted soil while it's in the mold and to the base. Remove the soil from the mold using a mechanical extruder. Take soil samples for determining the moisture content from the top and the bottom of the specimen. A sample calculation is shown here. We know the specific gravity of the sampled soil. The volume of the mold is known. For each trial, we determine the weight of the mold with wet soil. From here, we can determine the wet unit weight of soil. By oven drying of soil samples, we determine the moisture content. From the following formula, we can determine the dry unit weight of soil. The dry unit weight along with moisture content can be plotted in a normal graph. From the peak point of the graph, the optimum moisture content can be found. The maximum dry density is the dry density of the corresponding optimum moisture content. Finally, the zero air void curve can be obtained from the corresponding formula. Thus, the optimum moisture content and maximum dry density of soil samples can be determined.